All right, let's take a look at question number 18. In question number 18, we're going to be looking at how to generate exponential models. We're going to be looking at the compound interest growth functions for scenarios where the growth is continuous and a scenario where the growth is discrete. Okay? Question 18 reads, Kelly Ann has $20,000 to invest. She puts half of the money into an account that grows at an annual rate of 0.9% compounded monthly. At the same time, she puts the other half of the money into an account that grows continuously at an annual rate of 0.8%. Question: which function represents the value of Kelly Ann's investment after t years? And we have four options here. All right, so we're going to be looking at two exponential growth formulas to help us with this process. The first one will be the discrete one, where the interest is compounded monthly. All right, that will be the discrete, and the other one will be continuously. All right, so let's look at the two formulas separately, and then we're going to unite them together to solve this problem. All right, so the formulas that we're looking for, these are the formulas for compound interest. There are two of them. The first one is discrete, which is, well, we have n times per year, n times per period. Okay, n times per year or period. This is known as the discrete model. And for this one, the amount is going to be, well, let's use the f of t notation to be consistent with what we have here. F of t is going to be the initial amount, a1 plus, that's plus a1 times a1 times parenthesis 1 plus the rate in decimal form over n raised to the nt. Alrighty? Okay, how about the continuous one? The continuous model, what does that look like? For the continuous model, we have f of t equals the initial amount a1 times e raised to the nt. Bam. All right? So that's what we have. In Kelly Ann's scenario, we are looking at a combination. She's using the best of both worlds. She's using the discrete and the continuous. All right, so her function, f of t, is going to be a combination of both. All right, it's going to be a1 times 1 plus r over n raised to the nt. This is the one that is compounded monthly at 0.9% plus the other one is going to be a1 e to the nt. Okay? Now for both of them, what we're going to do is we're going to oh, real quick correction. So I made a mistake with my formula. So it's RT, not N. So this is supposed to be R, and that's supposed to be R. Okay, so A1 e to the RT, and this right here is A1 e to the RT. Alright, so let's go ahead and write down all the knowns and unknowns for both scenarios, and then we just plug it in and then see what the final answer is. Okay? Alright, so for the one that's monthly, in this particular case, what's the initial amount? She started with 20,000 and she split it in half. Okay, so the first half goes here. So you know what? We can call this A1 for the first one, and then we can just call this A2 for the second one. Alright, so for the first account, her starting amount was half of 20,000, which is 10,000. Okay, and then the rate R is what is it? 0.9%. 0.9%. Ladies and gentlemen, this is a trap right here. You must convert your percent to decimal. Even though this is a decimal, it's still a percent. Okay, so to convert this percent of a decimal of in percent form into actual decimal, we will have to move our decimal point 2 places to the left. 1, 2. Very, very important. Let me put a star here. Whenever you're working with compound interest formulas, your percentages must be converted to decimal form. So the rate is going to be 0.009. Alrighty? And then n is the number of times per period, is monthly. How many months are there in a year? There are 12 months in a year. And then our t value is just t, since we're looking for our investments after t years. Okay, so with this information, we can formulate the first balance of the account of a first balance, which is a 10,000 investment in the discrete growth model. So we have 10,000 times 1 plus the interest rate in decimal form, 0.009, over the number of times a year, which is 12 months in a year, raised to the nt, which is 12t. Okay? All right, now for the second account, we're going to add that on. She put the other 10,000, the other half, in here. All right? So for this one, all we need is the rate. The rate is 0.8%. The time is just t, because we're looking for her balance after t years. So in this particular case, we're going to have A2, which is 10,000. E to the r, the rate is, should I put 0.8 here? 0.8, should I put it here? The answer is no. Remember, we talked about this earlier, that the percentage must be changed to decimal point form first. So 0.8% is 0.008. Now, how did that